Here are the solutions to the third practice quiz for the second quiz in the third trimester of Algebra 2. So again, you want to divide this backwards, and you're going to find out that indeed you do get the same value each time. Okay, it's 0.2 in y equals a times b to the x. So 200 times 0.2 to the x is it. So make sure you check that out. I've given a few where this does not work. You don't get that same value. Okay, and you'll notice here as you divide backwards, you get 2 and then 2 and then 2, but 3 divided by 2 is not 1.5. So this fails on the last division. So a value of b, it's close, cannot be established. All of them have to work in y equals log base b of x. So it's very close to log base 2. You get 2, 2, 2, but you need 1.5, and you don't have it. Okay, so it's making it very straightforward, and what has to happen, divide it backwards, and it's got to work. All right, so all the same idea here. Some of the intercepts might be a little harder to get. -2, right here. Okay, so whatever is added on the end there, that's your horizontal asymptote in this case. 4 to the x minus 2, oops, to the x minus 2, minus 2. You can go to your table, and so you can see an x-intercept there. That's nice. And you can see a y-intercept too. How nice is that? So if you can get that, that's really nice. -1.969. I'll show you how on each of those. So the domain is always going to be all reals, and then the range on logarithm is going to be all reals. So that's something you probably can immediately just jump to. Okay, so is the range, so these are related, is it greater than -2 or less than -2? It's greater than -2 because it's sitting above it. You know, so literally, if you just wanted to kind of draw a dashed line through here, that graph's going to get really close to that dashed line. And you just need to make sure that you show that. So 4, 6, right there, it's really, and then about -2. And there's not, even though it's getting really steep, there's not a vertical asymptote. It kind of looks like it, but it does just keep going farther to the right and out because it's so steep. So how do you get the x-intercept? How do you get the y-intercept? So the y-intercept's where you let x be 0, and you do this calculation. You do 0.5 times 4 to the -2 minus 2. So when x equals 0, that exponent is -2. So there's your -1.969. Now the other work, so your y-intercepts can be done main screen. So you notice down here when you let x be 0, let's talk about them back and forth. You get log of -4. That can't happen. No, no, no. So y equals 0, and then you got to solve for x on both. So when y equals 0 on this one, 0.5 times 4 to the x minus 2 minus 2. What would you do for the work? You would add 2. Remember, you got to get the exponential bare, like so. then divide by 0.5 on each side. That puts a 4. So now we have 4 to the x minus 2 by itself. So we're going to do log base 4 of 4 equals log base 4 of 4 to the x minus 2. Okay, so this is 1 equals x minus 2. So log base 4 of 4 is 1. The x minus 2 will drop down in front. Then you add 2 and you get 3. All right, so down here, you let y equal 0. And then we need to solve this equation. So add 1. And now we're going to get a base of 2. And each of these things go into the power position. So we have 2 equals x minus 4. So x is going to be 6. Let's see if indeed we're right. Okay, so we need to remember change of base, x minus 2 divided by log of x minus 4 divided by log of 2. That's a change of base minus 1. So we better see 6, 0 or we did something wrong. Hey, there it is. Okay, and again, b, when we let x be 0, we get log base 2 of negative 4. That does not work at all. Okay, so domain, vertical asymptote is going to be 4. Set this equal to 0, the x minus 4. And then just look at, is it to the right of it or left of it? It's to the right of it. All right, so we're ready to go. Maybe just another point to the right of 4. 8, 1, about right there. Just make sure that when you do this, you're getting very close to, I messed it up, very close to 4 as a vertical asymptote. Okay, that's the important piece there, that you get close to that. We'll just wipe this out. Looks like I haven't used this in a while. All right, so last page, everything but this interval, 0 to 3. So this is greater than 3, this is 0 to 3, and this is less than 0. So you need to see those 3 intervals all the time. And so we want the 2 where the graph exists. So you should be able to see those 3 intervals regardless of what's given to you all the time. And maybe the graph is actually in this piece of it, but there's still the 3 intervals that you have to see. Okay, so these are the solutions for the 3rd practice quiz for quiz 2 in the 3rd trimester of Algebra 2.